Okay, so we are going to start the lab 3 orientation video. Now here I'm just trying to show you that how exactly you will work in your lab. Okay, this is extremely important, and you should look at what I'm doing here, and you will try to follow the same steps when you will be doing your lab. So for doing the lab, we have a manual, right? We all have the manual, right? So I just gave you a manual, and you will also have your tools like your breadboard I'm showing you here, right? So you will be actually building your circuit here in the breadboard, right? So I'm putting the breadboard here. You will also need a cutter stripper like this one. This is a very basic one. I'm sure that you have seen it before, right? In the first class. And you will also need a needle nose plier. So I'll show you some applications of these, that how you exactly will need it in the lab. We will also give you a digital circuit parts kit like this one, where you will actually have all the ICs you will need for this class. Remember all the gates, the NOT gates, NAND gate, and all the gates like basic and all the other gates like NAND, NOT, exclusive port. Those gates come as an IC, right? And remember the lecture we had for the chapter 3, in one slide we actually have the names of numbers of all the ICs with different gates. For an example, for all the NAND gates, 2-input NAND gate, the number of the IC is 7400, right? So we'll be actually using that IC for that one. So let me show you how actually we'll do a lab. So here is our lab 3. Now in each lab, what we do is we actually go to pause. Now if you go to pause, you will see in the lab section we have all the labs listed, right? Now let's say you are doing lab 3. Now if you click lab 3, you will actually see all the labs, all the resources we have for this lab. For example, in this lab we have actually 4 parts: 3A, 3B, 3C, and 3D. Okay. Now for each of the part, we have a schematic. Now if I click the schematic, you will see how it looks like. Okay. Now this is actually your main resource. We also have a schematic in the manual. Okay, for the same labs. If you go to the manual and open it and then go to the lab 3, you will find a similar schematic. Okay. But remember, some of the schematics in the image we have in pause or in manual are not exactly same, but that's actually the same circuit. Okay, so it doesn't matter which one you follow, whether you follow the one we have here or you follow the one we have in the manual. Okay, it doesn't make any difference. It's up to you which one if you want. Now let's say for this is the schematic for 3A. We also give you an example image for 3A, meaning all the labs. Okay? For an example, if you look at this one, I'm just trying to introduce you what exactly you will have in the lab. Now look at this. This is exactly how the circuit would look like, okay, once you build the circuit in the board. Okay. Now, again, as I said, this is actually a sample. You should always use actually the schematic, okay, to build the circuit. This is also, of course, a resource. This is a sample image which actually tell you how your circuit should look like when you build it. But remember, you just have finished the quizzes, right? Pre-lab lecture and quiz. Now, if you can recall, for an example, let me show you a couple of things here just to make sure. For an example, you know that all these points, for an example, in one column is short, right? Meaning all these points are actually same point. You see what I'm saying? Because they are short. Okay? Now, for an example, you can pick any column here, no matter which column you pick. Now, each column is actually short. Now, in each of the column, you have, for an example, in this breadboard, you actually have 5 points, right? In each of the column. Now, all those 5 points are actually same point. That means what? It doesn't matter which point you pick when you connect the wire. Okay? Now, for an example, let's say you have a chocolate wire, right? Do you see it? Do you see the chocolate wire I'm moving my mouse on? Now let's say I connected here, right? Now instead of this, if I would have connected in these 2 points at the top, it would have been still the same thing, same circuit. Because those are actually the same point, right? I'm saying all the points you have on that column is actually the same point. It doesn't matter you connect here, okay, or here or here. So that means your circuit that will be building doesn't have to be exactly matching with this. Don't try to match exactly with this, because I have seen it before. Almost everybody try to match with it. It doesn't have to be exactly matching, because it may be a little bit different here and there, because all you are actually trying to do is just following the schematic. Okay? So that's why today I'll show you how you actually use your schematic to build the circuit. For an example, let's say if I choose this one. Okay, and also just don't forget, in some of the lab we also have some more resources. In addition to the schematic and image, we sometimes have like steps. Some of the future labs, which are longer, right? You have to make like big circuit. We also have steps, okay? In plain English, we just said, okay, do this first, then do this second, right? We just told that as well. So, you know, we'll be using all those resources. Okay, but let me show you what exactly we'll be doing. For an example, for each of the lab, what we can do is this. Let's say this is our lab 3A, okay? Now, I got this schematic. You can see the schematic, right? I got this schematic from, let's say, from POTS. I just printed it out, okay? We also have the schematic in the manual, so it doesn't matter. So if you have your manual, let me tell you which page you should check to get this schematic. That is in page number 9. If you are looking at your manual, you can check the page number 9, but it may not be exactly same with this one, but that's actually the same circuit. Now, again, the schematic means a digital circuit, right? It's actually a digital circuit. And all you will find in the schematic is, for an example, if I make it a little bit, I zoom it a little bit more so that you can see more closely. All you will see here is all the gates that you see in the quiz, that you see in the lectures, right? For an example, if I look at these schematics, you see these are what? These are registers, right? I'm sure we all know how the registers look like in the schematic, right? Electric circuit class, right? These are the regular registers, right? And not the, I should not say probably regular. It's 220 ohm register. In this class, most of the registers we will need for this, you know, the building the circuit will be 220 ohm register. But in some labs there are exceptions. But most of the circuits you will need 220 ohms registers. But we mentioned, right, that 220 ohm. You will see that mentioned in the circuit. If I let me zoom it a little bit so that I can show it a little bit more closely, just to make sure what you see. Now, let's say, okay, what I have else here, I also have, what is this gate? What is this gate? It's a NAND gate, right? Remember the NAND gate? I think you have been doing all the quizzes, right? You should see this now. You know, by now you should be identifying these gates. This is the NAND gate, and we have also written 7400. Now, what do I need to write this? The reason is this NAND gate comes as an IC. Remember, all the gates come as an IC. The number of the IC is 7400. Okay. Over the time, you will pretty much memorize it. You don't have to, but you'll be, you know, using those so many times, so many, you know, ways. You will actually have to memorize it. And also, what is this gate? Inverter, right? What is the number I have written? 7404, right? So that means this is the number of the IC. Okay. So, and there are two registers here, 220, 220. See, all the registers we have here. How many registers I need? Like 1, 2, 3, and 4, right? I need like 4 registers, and all the registers are 220s, right? Meaning at the beginning, I should check what I need, okay? I need like 4 registers, and what are these? Can you tell from the electric circuit class, what are these A's and B? Switch, right? I'm sure you have seen it in the electric circuit class, right? And you see this circuit is also grounded here, right? Now remember, any digital circuit that we will be building in this class, you will see either, you will see always like two different connections for the voltage. One will be connected to the voltage 5, which is actually our logic 1. Okay? Another one will be connected to the ground, which is like voltage 0. Okay? Once you build the circuit, we actually go to the lab. In every station in the lab, you actually have a 5 voltage and 0 voltage. So you will be actually connecting the 5 voltage where we need the 5 voltage and connect the 0 voltage where you need the 0 voltage. Okay? We'll show you exactly how you do it soon. Okay, now we have 2 switches here. This is your power, meaning the voltage 5. See, the voltage 5. Sometimes we just write VCC. Okay? That's still mean by voltage 5. Okay? Because as I said, voltage 5 or voltage 0, nothing else, right? Ground means 0, VCC or voltage 5, whatever it means, voltage 5. Okay, now you also need, do you see these? These are LEDs, right? Have you seen LEDs? I think you should see LED in the digital circuit class, I'm saying electric circuit class as well. There will be a couple of LEDs because remember, in digital circuit we try to see whether the logic is 1 or 0, right? That's all we try, right? Remember in the quizzes, all you have tried is what? In every question, when you have a circuit, you have to answer what? What is the output? Either 0 or 1, which is sometimes easy because a lot of people think, oh, we don't have to do it, just guess, right? But because when you guess, still you have a chance of 50% that your answer will be right, okay? But don't trust on your guess. Everything may be wrong, right? But again, the LEDs are used here to see what is the logic. For an example, if you want to check a logic in one point, actually we plug an LED. And just by the LED, we see whether the LED is turned on, that means what? The logic is high, right? If it is turned off, it's 0, okay? Because we just want to see how the LEDs are working, and based on that we saw, okay, now the logic is 0 and logic. And as I said, even if we are talking about the voltage now, but most likely we don't talk about the voltage in the digital circuit, right? Look at the question you have in the quiz. We don't have any question probably with the voltage, right? We just said, oh, logic is A is 1, B is 0. Can you tell what is the output, right? Most of the time we just ask this question because it's just based on how the logics, based on the logics and how the logics will be changed or modified or in the circuit. Okay, now let's see how we can build this circuit. I'm just trying to show you a very basic and simple circuit and show you how we can use these to build a very small circuit very quickly and efficiently, okay? Now, remember the image I showed you, from pause? In the image, you may have seen that all the wires we used is actually very small and tight enough because we don't want very long wires in the circuit, okay? We actually want very small and, I'm saying, very small and tight wires like this one. You see all the wires? Do you see we don't have any long wires? Do you see it? Okay? That means this is our preference. If somebody keeps a long wire, the circuit will be still working. You see what I'm saying? But most of the time we prefer to have the cut the wires very small and tight so that you can actually, it looks neat and nice. In addition to looking neat and nice, there is one more thing, which is when your circuit is not working, for an example, it's likely that your circuit will not be working. You build it first, it may not be working, and there may be 100 reasons why it's not working. We actually have to follow some steps like troubleshooting to see whether it's working or why not, why yes, those things, right? We'll also teach you in another lecture how to do that once we start lab, starting from the next class. But when you have these small wires, the good thing is, if the circuit is not working, you can see how the wires are connected, okay? If you keep really long wires, the problem is, if you have too many connections, everything will be messed up. And the whole circuit will look like a forest of wires. And it's really hard to fix it and see what was going on and how the wires are connected. It's a very small circuit, the one that you see in the board, in the projector right now is a very small one. But the most likely the circuit you will be building in the next labs, because this is the first one, right? The future ones will be bigger. I'm saying it will be more exciting, right? More connections. So we want you to keep the wires small and short, okay? Now, I'll not be using small wires now because it will take a little bit longer to cut the wires and strip it. So I'll actually show you how to build the circuit very simply, okay? Let me again go back to the camera here. All right, let's see. Now this is my breadboard here. Okay, so far we have some understanding of how the breadboard works, right? We know what do we know here? We know that this line is short, right? The bottom line, rail, this is short, right? This is also short along this line, but all these columns are short as well, right? And all these columns are also short, right? Each of the columns are short, meaning they're exactly the same point, even if you have like 4 or 5 points there. And you have a bottom rail and top rail, those are short as well, right? But you might have 2 rails at the bottom or at the top based on your breadboard. Okay, this is a very basic one. You might have a fancy one, right? Now let's start very quickly. Now look at this. We have a switch at the beginning, right? We have a switch, and switch is the one which you use to manipulate the input. That means to change the input. So for an example, let's say I have a switch here. Do you see the switch, how it look like? Can everyone see the switch? Okay, now what do you do is we always plug the switch somewhere in this side. Okay, I'm plugging the switch here. It doesn't have to be exactly here, but somewhere here. You see how I'm plugging the switch? I'm actually putting, you see, in the back side, you see there are two rows of pins, right? You see in the top rows of pin, and if I put it very close, or if you look at very close, you might see something written here, right? It's written open. Do you see it? You probably cannot read it, but you can see there is something written, right? This is written open here. Now that open should be at the bottom, okay? So I kept the open here, and I'm actually I'm pushing it a little bit, because if I don't push, it will not plug it right. I pushed it, so the switch is already plugged, okay? Now, what other IC I need? For this circuit, remember I was showing you the ICs that I will need for this circuit. You will need what? If I go to the schematic and look back the schematic again, I need what gates I have. I have NAND gate and I have inverter, right? I have NAND gate and inverter, so I actually need 7400 and I also need 7404, right? Now, in your package, remember I said I'll give you a digital circuit kits, parts kits, so you will see all the ICs there, okay? Now let's say these are the 2 ICs that I have, okay? Now let me see what ICs I have. Now I'm not sure whether you can see these. I'm trying to make it, let's see whether I can. This is actually 7400. I'll show you more closely. Let me plug it here, because I know that I'll need 7400. But let's see whether I can zoom it a little bit so that you can see a little bit more closely and see how the ICs look like, okay? Now this is actually the IC, and then if you try to read here, you might be able to read. Let me show you. I'm not sure whether you can see. Can you see 7400 there? This is actually, this is written 74, then S something, and then 00, okay? So what happens is, in most of the ICs, based on the manufacturer, most of the ICs, they write 74 and then they write some 2 letter based on their manufacturing something, and then they write 00, okay? It will be not like 7400, it will be like 74, then 2 letter, then 00. But for sure you will see 00 there, okay? That means that's a NAND gate, okay? Now, and again, one thing is, when you plug the IC, if you look at more carefully, let me show you here. If you're more careful, do you see there is a curve here in this side? Do you see there is a curve? So that curve has to be on your left, okay? Because that curve, do you see the curve here? Do you see the curve here? Small curve? That curve has to be on your left. So I kept it on left, and I'm putting the IC here, okay? See, I put the curve here on the left, okay? Now, you see the IC means you have some pins, right? How many pins you got? you actually have 14 pins in this IC. 7 at the bottom row, and 7 pins here, and you have 7 pins here, right? Now, how do you start reading the pin? Because you have 14 pins, right? Now, the point is, which pin is number 1? How do you know it? I'm saying these pins are numbered. They have specific numbers, and number is extremely important, okay? So remember I said that you keep basically the card in this side, right? That means this pin will be the pin number 1. And you will start reading any IC. If you keep the card on your left, this pin will be number 1. Then you will start reading like this. Number 1, number 2, number 3, number 4, 5, 6, 7, right? And then go to the top, 8, 9, 10, 11, 12, 13, and the last one is 14. Do you see how I'm reading? So you actually start from the very bottom, left side. Make sure your card is at the left side, okay? And then read all the way down to the end, and go to the top, keep reading continually, yeah, okay? And all the way to the end, okay? So there are 14 pins now. Now, how do I know which pin is what? So what I do is, I'll actually take the help of the manual I gave you. If I go to the very end of the manual, for an example, if you go to the page number 107, can you go to the page number 107? If I go to the page number 107, then do you see page 107? Now the page 107, let me show you the page 107 here and what I have in page 107. So this is actually the page 107. Now see here in the page 107, at the beginning it's written 74LS000. That means this is a data sheet for the IC. Now for every IC, we have a data sheet. Now almost all of the data sheet you can find online, but still just to help you out, we also gave you the data sheet at the bottom of this, at the end of this manual, okay? Now this is 7400, meaning the IC just we are using, right? Now if you look at the IC, what do you see here? Look at the IC. These are pin numbers, okay? So this is starting from 1, okay? 1, 2, 2, all the way to 7, and then it's starting from 8 to all the way to 14. Just like how the ICs were, the IC was there, right? And then if you look at the IC more carefully, you'll see that in this IC, we actually have, how many NAND gates we have here? How many NAND gates? We actually have 4 NAND gates, right? Now how many NAND gates you need in your circuit? Just one, right? Now tell me which one you are going to use. You can actually use any of those, so which one you like, it doesn't matter, okay? So you actually have 4 here in the IC, you just need 1, so you can pick which one you like. But be careful, because you see, you check the input and output, right? For an example, can anyone tell me what is the input and output for this IC? Meaning, which is the input pin and output pin for this IC? So 1 and 2 are the inputs, right? And the 3 is output. So be careful. So if you are using the first one at the bottom, right, you know that 1 and 2 are the input and 3 is the output, right? Okay. And also remember, to make any IC to work, you must have a ground pin and a VCC pin in every IC. VCC means voltage 5, ground means 0. Okay. Now you always have to find it. Now if you look at this one, the number 7 is ground. This is written GND here, which is ground. And number 14 is actually your VCC. Okay, so it doesn't have to be 7 and 14 in every IC. You actually have to look at the data sheet every time which IC you are using to see which is ground and which is VCC. That means those pins has to be connected with the ground and VCC for the IC to be working correctly. Otherwise, IC will not respond. I'm saying everybody needs power, right? Without the power, it will not work. Okay, so every IC has to be powered up. Okay, now that's the data sheet we have for 7400. Now let me. So now this is my 74. Okay, now let's get back to the circuit again. This is my 7404, meaning the inverter. I'm again plugging the IC somewhere here. I'm keeping some space so that I can, run the wires and, just keep some space because we don't have too many circuit here. So I'm just keeping a space here and plugging the same way because I kept the curve here, okay? Be careful, you have to have the curve here, okay? Otherwise the RTSC will not be working. Now, okay, all right. So let's go back to the circuit now and see. So do you see number 1 and 2 given here and 3 is written here? That means these are the pin number given to you, okay? Now since this is the first circuit, we said pin 1, pin 2, and then output is pin 3. Starting from the next circuit, we'll not be giving you the pin number. You actually have to find the pin number from the data sheet. Because you saw the data sheet, right? You know exactly which pins, you can pick, right? So, to get a circuit, I'm saying the gate to be working, okay? Now, so I have my switch, I have all the gates there, okay? Let's see whether I can run some wires to make it work. Now, every time what I'm doing is, so if I look at the switch here, can you tell me how many switches I need? How many inputs I have? Look at the data sheet, look at the schematic. How many inputs you have? How many switches you have? 2 switches, right? That means you actually need 2 switches only. Now, how many switches you have in the red deep switch? This is called deep switch. You actually have 8 switches here, okay? But you need only 2. Now, which 2 you pick? Any 2. It doesn't matter. I'm saying it's just the same, right? You'll be just choosing any 2. It doesn't matter, okay? Now, let's say I'm choosing, let's say first 2, okay? Number 1 and number 2. It doesn't have to be number 1 and 2, right? Okay, now, you also have noticed in the schematic that there are some registers here, right, with the switch. And there is also connected to the ground at the bottom here, right? See, the ground, right? So, what we do is we connect the register here for the switch column. Now, let's say I'm using the switch 1. I'm plugging the register from switch 1 column, right? And this is my power. In this rail here is actually for the power, meaning anything we need the power will actually connect into this row. This row is short, okay? So we connect to this row, and this row will be in one pin. Will be connecting this row to the power station. Remember, when you go to the lab, you will have a station and you will have the power voltage 5, right? You will connect the voltage 5 to this row, okay? So I'm not plugging my register from the switch 1 column to this any of this point. Now remember, you can choose any of these, okay? Any of these, doesn't matter where you connect, okay? Now when I plug here, see, this is my column, right? I could have chosen any point of this column, so don't assume that it has to be this point. Meaning on that column I have 5 points, right? In this column, right? In this column I have 5 points, right? I could have chosen any point and connect this register to any point because all those points are same point. Because those are short. Okay? Now, I did one register here because that's just the switch 1, and this is a 220 ohm register. Okay? Now for another one I'm doing the same, okay? But I'm choosing any of the point. As I said, I can choose any point, and I'm connecting to the other switch. Okay? Now that means what? That means let me do it a little bit, shift it a little bit upward so that we can leave some space here, but that's still the same thing, okay? Let me move it here. Remember, there is still the same thing. Sometime you will need this needle nose plier to actually push it down to the bottom of this breadboard, okay? So that's why you need the needle nose plier. You have to actually push it down, okay, so that it actually touches the ground. I'm saying the bottom of the breadboard, okay. Now you also see that with the switch we have a ground connection, right? So for each of the switch we are using, we'll be connecting a wire. We'll be running a wire from the other side. You see this from this side. For the same 2 columns, we are running the wire from here, from any of the point in this column to the ground. Now this bottom row here is actually will be used for the ground. Remember, once you go to the lab, we'll connect the ground to this bottom row. We'll connect the VCC, meaning the power voltage 5, to this top row. Okay. Now this is my ground here. Okay. So I'm connecting one of the one switch to the ground. Okay. Now I have to connect the other switch to the ground as well. So this is the other switch here. So I can choose any of this point. Okay. No matter which one, I can choose any of these points. I just chosen one. Doesn't matter because all the points are same, right? To the ground here. So my switches are ready right now. Now for each and every lab you will be having in this class, you will need a switch. You will need some switches. Sometimes you need 2, sometimes 3, sometimes 4, but all the switches will be similar, like this. You will have a register at the top connecting to the VCC, wire at the bottom connecting to the ground. Okay. Now we are done with the switch. Now let's say what I have from switch A. Now let's say I am assuming the switch A is my left one and switch A is my right one. Okay. From the left switch, what I'm doing is I have to run a wire to pin 1, right? Do you see it? Look at this. From switch A, I'm running a wire. This is not connected here. I'm running a wire to pin 1, right? Pin 1 of what? 7400, right? So let's try that. Now that means from the switch 1, that means from here, okay? From here, from switch 1, I connected the switch 1 here to pin 1, right? Pin 1 means here, right? But remember, I can connect any of this point in the column, doesn't matter. Any point here, you see what I'm saying? Because all the points are same. So I just chosen one point. Let's say I chosen this one. This is the pin 1, right? You see what I'm saying? Okay, now I'm done with these. What else? From switch B, I will be running a wire to pin 2, right? Do you see it? So let's do that. From the switch 2, now let's say this is my switch 2, right? This is my switch 2, right? This column here is my switch 2, right? So I can choose any of the point here. So I just chosen one and connecting to pin 2, right? Pin 2 means what? Any point here in this column, right? So I just chosen any of the point, okay? It doesn't matter. So I just connect. Remember, you have to push it, right? If you cannot push, use the needle nose plier to push it, okay? And remember, you might have to cut and strip the wire before you use it because I'm using a long wire, but you should not use the long wire. You actually use it, small as neat and clean possible, okay? Now, we are done with these two connection, right? Now look at this other one. I have to run a wire from pin 3 to pin 1 of 7404, right? Do you see this connection here? Okay, now let's try that. From pin 3 to, so this is my pin 3 here for 7400, right? I can choose any point. So I'm connecting here from pin 3 to pin 1 here, right? You see what I'm saying? I did that. So I'm done with here, this. And now I'm almost done. What I need is, I need actually to connect a register to an LED to ground, just to show the output for this point, okay, for pin 3, and for pin 2 I do the same, okay. Now to do that, what I'm doing is, let's say from pin 2 I actually need to run a register, right? I can probably use a register directly. Again, this is a 220 ohm register. Remember the color bands, right, from the EETC circuit class. I'm not explaining the color band again here. So this is my pin 3, okay, from the same pin. See, you can use the same, this is my pin 3 here, right? So you can use the same column again because you have many other points not used yet. So I'm using another point to run a wire because from the pin 3 you actually have to run a wire from pin 3 to 1 and again pin 3 to a register, right? So I did that. Pin 3 to a register to a free column. Now what do I mean by free column? All these columns are free, right? Because these are not used with anything yet, right? So I'm just using one of the free columns here. I connected to one of the free columns, right? And then let's say I'm using one of the free columns. I use my needle nose plier to plug it tight, okay? To plug it tight. And then I have to connect an LED, okay, to that column. Now remember, if you look at the LED, see, if you know that LED will have 2 legs, right? But if you look at more carefully and closely, you will see one of the leg is always shorter than the other one. Now here in this LED, this is actually the shorter leg. This is the longer leg. Shorter leg will always go to the ground. Okay, now what happens is I'm connecting to this column, right? So I'm putting the longer leg here. This is my longer leg, and then shorter leg is going to longer leg. I'm connecting the longer leg of same column. Okay, I'm connecting the longer leg here, and then shorter leg will be going to the ground. That's kind of any point is the ground, right? Here, any of this point is ground, right? Because I'll be connecting this with the ground. This is short. This row is short, right? So I connect it to the ground, and same I'll do here. From the other side, let's look at the schematic again. I actually have one more connection left here. From pin 2, I have a register running to the LED to the ground, right? This is the ground, right? See, this is actually the ground. Now from pin 2 of the second IC, which is 7404, now this is my pin 2 here. So I'm running a wire from pin 2 here. Let's use my okay, I'm using my needle nose plier and use a free column. Anytime you need a LED, use any free column which is not used before. I'm pushing it here, and then I'll be using an LED again, just like how I did before. Longer leg here. This is my longer leg. I'm connecting my longer leg here. This is the longer leg. The longer leg, and this is my shorter leg going to the ground. Okay. Okay, so this is my shorter leg, and this is my longer leg. Okay, this is my longer leg. Okay, because the shorter leg always goes to the ground. Now, I'm pretty much done with this circuit following the schematic here. So all I did is I just followed the schematic and built the circuit. Okay. Now, what is still missing? Do you see anything missing here? I pretty much followed everything that we had in the schematic, but still I have something missing. What is that? Do you remember when I started talking about the IC, I said every IC has to be grounded and has to have a VCC. We have not done yet with that, right? Now, if I look at my manual means this data sheet, okay? This is the data sheet for 7400. If you just go to the next 2 pages, you will find the data sheet for 7404, okay? Now here, same is true. The pin 7 is ground, pin 14 is VCC. Okay, same is here. Pin 7 is ground, pin 14 is VCC. That means for each and every IC, I have to find the ground pin and I have to find the VCC pin, and I'll be connecting those as well, so that the IC must be working, right? Now let's do the first one. Now for 7400, now this is my pin 7, right? This is the last pin at the bottom, right? Bottom row. So that's my pin 7, right? Here, the last one. So I'm connecting the pin 7 here, the connection here, using my needle nose plier to push it here, and then connecting the other side to the ground, because the pin 7 has to be connected to the ground, right? So I'm just connecting this to the ground. Okay. And then pin 14 has to be VCC, right? Which one is pin 14? I started counting from the bottom, right? Went all the way up to 7 at the bottom, then 8, 9, 10, all the way up to here is 14, the last pin, right? That's my 14. So I'm connecting the 14 here. I connected the 14 to the VCC, so that means any point at the top, right? I can choose any point from the top row and use my needle nose plier to connect it, okay? Now, so we are done with the power for the first IC. We'll do the same for the second IC, which is connecting the power here, pin 14 to VCC, right? So pin 14 to VCC, okay? I'll be also doing the ground. That means pin 7 here. That's the pin 7, right? Connected the pin 7 here. From pin 7 to ground. Now that means any point you can choose, right, from the ground. You can choose any point from the ground. So let's choose one of the point here, and then you can push a little bit with your needle nose plier. Okay, that means your circuit should be ready by now. Okay, now once you go to the lab, you will need the power, right? That means you will actually need the power to be connected. That means you will need the VCC to be connected at the top row, right? So that means you will be actually leaving a wire like this, open on one side, and this open side will be connected to the voltage 5 with the alligator clip. Once you go to the lab, you will find some alligator clip. So connect the alligator clip with the voltage 5. So this will be your voltage 5 because this is connected to the top row, because the top row is the VCC, right? And for the ground row, you need what? You need the ground, right? Connected to the voltage 0, right? So let's do that. You can choose any point from the ground row. Let me choose this last point here. You can choose any point, okay? And then connect this open wire through the alligator clip with the voltage 0. Now once you do that, your circuit should start working. Now, how do you know the circuit is working? You actually have to flip the switch, right? Make it 1 and 0. Remember? You have to check what? You have two inputs, right? So you have to check 0, 0, 0, 1, 1, 0, and 1, 1, and record all the outputs. Now how many outputs you have? 2, right? Because you have 2 LEDs. So you actually see if the LED is turned on, that means you have a 1 there, right? And from the schematic, you know what those points are, right? For an example, let's say if I go to the schematic, right? If I go back to my schematic, I can tell what points are those. Let's say I'm assuming this is, let's say, my point X, meaning this LED is actually the point X, and this LED is actually point Y, for an example, okay? So for my switches changes, I'll record what is the X and what is Y. If X is turned on, that means X is 1, right? Y is turned off, that means Y is off. Now, how do you know which, we have switches here, right? Now, how do I know which is, what is 1 and which is 0? That means if you press down at the bottom, that means that's 1. If you press down at the top, that means this is 0. Okay? I don't know, I can show you here. That means, let me show you here. Do you see anything here? Now, if I press it bottom here, down, that means it will be 1. Okay? If I press it down at the top here, then it will be 0. Okay? That's how I can actually switch between zeros and ones and build the circuit. Now, you can again go back to this lecture video to see before you start, okay? Now, next class, we'll actually start the lab. So make sure you bring your tools, and you already have the manual. Once you finish the quiz and look at this orientation video once again, you will exactly understand what you need to do in the labs. Most of the labs are like this, except the circuits will be bigger, exciting, different, right? A little bit more IC, right? So with more connections. And I just kept the wires longer because we don't have time to make it shorter, but I recommend all of you make sure the wires are small and shorter, look neat and nice, okay? So that it's easy for you to debug in future if you need to, okay? In a different lecture, we'll talk about how we actually fix the circuit if it is not working. And it's likely that if you build it, it's not working for 100 reasons, okay? And you have to be patient, again, and you have to troubleshoot, and we'll show you how actually you troubleshoot and you circuit, fix your circuit to make it work, okay? All right, let me stop this presentation here.